Alright, hi, welcome to an introduction to gas distribution. It's a little bit too much there. Introduction to gas distribution, John Paul Geyer, PE, RA, editor. Powers registered civil engineer, mechanical engineer, fire protection engineer, architect, 35 years experience, design building related infrastructure. Official 9 years, he's principal staff advisor, California legislator, capital output, infrastructure issues. Graduated from Stanford University, has numerous national, state, local offices with American Society of Social Civil Engineers, Architectural Engineers, and National Society of Professional Engineers. He is a fellow of UASCE and AEI. Our contents will be the contents of this intro to gas distribution, introduction, purpose, safety requirements, pressure classes, distribution systems, system planning, materials and equipment, miscellaneous plans and engineering data, gas distribution systems design. This public document is adapted from Unified Facility Criteria of the United States Government, public domain, been authorized for a limited distribution and are not copyrighted. For your tables, equations, publications, many of the times a little difficult to read, but they are best available. Do not purchase this publication. This limitation is unacceptable to you. If this limitation is unacceptable to you. Our introduction publication contains instruction and engineering information relating to gas distribution piping systems, including pressure regulators, valves, meters, and other necessary appurtenances for the distribution of fuel gas, fuel gas is natural and manufactured from the point of delivery to the gas supply over the point of connection with the building piping. 2. The purpose of the furnished with the God is designed with a new gas distribution system, checking the adequacy of the design finished with the gas suppliers for the analyzing existing system and to determine the adequacy of supplying with the demands of proposed additions. Alright, 3. Safety requirements. The design will include safety requirements at ANSI B318, including guidance from the abandoned gas lines. This requirements for the ANSI B31 8 are adequate safety under conditions normally encountered with the gas industry. Requirements for the abnormal and unusual conditions cannot be specifically provided in this publication or all the details engineering prescribed. Alright, 4. Your pressure class of the distribution system. Low pressure system. A low pressure gas distribution system. Gas pressures main surface line is the substantial same as the delivered to the user appliances. Such system surface regulator are not required for the individual service line. So, once again, your low pressure system is a gas distribution system with the mains and service lines substantially the same delivered to the using appliances. In such a system, that the service regulator is not required to individual service lines. Your high pressure system. A high pressure gas distribution system operates a pressure higher than standard service pressure delivered to the user. In such system, service regulator is required on each service line to control the pressure. Alright, 5. Your system planning layout. Gas distribution system will be planned carefully with a due to consideration, economy, safety, uniformity of the pressure. The lines will be well looped with the main area and outlining areas whenever practical, economically feasible to do so. It's not always practicable to loop supply line with the outlying area then back into the main system. But in such cases, the objectionable effects of the dead ends can often be relieved to some extent by looping such a line around the area to serve that then back into itself. A large station will usually be advantaged to extend high pressure line to provide 2 or more connections with distribution lines for the purpose of the uniformity and assurance of the adequate pressure. 5.2. Line out locations. Gas distribution system lines will never be under a building. They will never be laid in the same trench with other utilities, precluding with the possibility of leaking gas, following around, collecting other conduits, creating an explosive hazard. For the same reason, gas lines will be above the utilities whenever they cross. If practical, gas lines will not be laid under paved streets or in any other location subject to heavy traffic whenever practical or avoided. Whenever it is necessary to locate gas lines in such a location, lines will be protected with a suitable casing or bearing to a depth of provided at least 2 feet of cover over the top of the pipe. Sufficient clearance must be maintained between the plastic lines and plastic mains and steams hot water, power lines, and other sources of heat to avoid temperatures in excess of 60 degrees Celsius, which would be 140 degrees Fahrenheit. For thermoplastics, and 66 degrees Celsius, 150 degrees Fahrenheit for thermosetting epoxy resin pipe. 5.3. Drips will be insulated low points, inline transmitting manufactured gas mixture, national manufactured gas lines transmitting natural gas. Drips will be installed low points immediately following reduction of high pressure to low pressure. Occasional low points throughout the system will be provided with the blowing out of the lines. Alright, 5.4. Grading lines. Gas lines may be buried deep enough to provide at least 2 feet of cover over the top of the pipe. When manufactured gas is used, the lines will be uniformly graded to a drain low points, preventing low formation of pockets where condensation could result with a low flow of gas. Line transmittal natural gas need not to be graded, but may follow with the contour of the ground surface. 5.5. Valve spacing and distribution system. Whenever operation emergency use, valves on distribution mains will be spaced as required in the following subparagraphs. 5.5.1. High pressure systems. Valves will be installed readily accessible location, reduce the time of shutdown section in the main emergency. When determining spacing of the values, considering should be given the operational measure. Whenever determining spacing of the valves, consideration should be given to the operating pressure inside of the mains and local physical conditions, as well as the number of the type of the user services affected by potential shutdown. Alright, 5.5.2. Low pressure system. Valves are required a low pressure system only to meet conditions given in paragraph 1.6 below. 5.6. Location distribution system valves. A valve will be installed on the inlet piping of each regulator station, controlling flow of the pressure of the gas in a distribution system. Distance between the valve and the regulator or the regulators must be sufficient to permit operation of the valve during an emergency, such as a large gas leak, fire in the regulator station. Valves and distributions mains, whether for operating emergency purposes, will be readily accessible, easy operating during an emergency. When the valve is installed and buried in a box enclosure, readily access only operating stem and the mechanism is applied. The box or enclosure will be installed in a manner to avoid transmitting external loads to the main. 5.7. Pressure regulators. Pressure regulators are necessary at all points wherever the equipment design requires reduction and regulation of pressure. Bypass around pressure regulations will not be installed unless continuity service is imperative by the bypass suitable regulated to prevent possible overpressure of the downstream lines. Alright, 5.8. Control central regulating metering system. Central regulating metering system generally provided with a gas suppliers usually located near the entrance of the reservation. When provided with the owner, all necessary equipment will comply with the requirements of gas suppliers and enclosure. If required, will be fire-resistant construction such as masonry. Adequate provisions will be made with the ventilation design enclosure coordinated with the using agency. Gas supplier valve may be installed with the main supply line approximately 100 feet ahead of the station. 5.9. Protection against accidental overpressuring. Every distribution system meter of the connected facility will provide with a suitable pressure relieving the pressure limiting device. 5.9.1. Controlling line pressure and high pressure gas distribution system. Each high pressure distribution system main, which is supplied with a source of the gas, higher pressure maximum allowable operating pressure distribution system will be equipped with a pressure regulating with a device with adequate capacity designed to meet pressure load or other surface conditions under which they operate, which may be subjected. In addition to the pressure regulating device, suitable protective device to prevent accidental overpressuring must be provided. Suitable protective devices are as follows: spring-loaded relief valves, confirming with the American Association of Mechanical Engineers boiler pressure vessels code section 8, division 1. Pilot-loaded back pressure regulators are used to relieve valves designed so that the pilot system control line failure will open the regulator. Weight-loaded relief valves. A monitoring regulator installed in series with the primary pressure regulators. A series regulator installed with the upstream primary regulator to so that the continuous alignment of the pressure on the inlet primary regulator to the maximum allowable operating pressure of the distribution system or less. An automatic shut-off device installed in series with the primary pressure regulator set off with the pressure of the distribution system reaches the maximal operating pressure or less. The device must be remain closed until reset manually. It should not be used if it might cause an interruption surface with a large number of the main within surface line, spring-loaded diaphragm type of the relief valves. Alright, 592, controlling limiting pressure to low pressure gas distribution systems. These low pressure distribution systems, low pressure main supplied with a gas source which is a high pressure than maximal allowable operating pressure. For a low pressure system, will be equipped with a pressure regulating device at adequate capacity. Other devices will be designed to meet the pressure load and other surface conditions in which they may operate. In the addition, pressure regulating device, a suitable protective device to prevent the accidental overpressuring must provide may be included. A liquid seal relief device can be set on open accurately and consistently at the desired pressure weight. Loaded relief valves, automatic shut-off valve described above, pilot loaded back pressure regulators described above, monitoring regulators described above, and series regulator as described above. Alright, 593. Your design requirements, pressure relief device, limiting devices. Such devices will be constructed of materials resistant to atmospheric corrosion external and gas corrosion internally. Have valves and seats designed so they will not stick in positions which prevent the device operating properly. May be designed and installed with each of the maintenance operation for check of the leakage, pressure rate, actuation, free valve movement. 594, telemetering and recording gauges. 5941, each distribution system supplied by more than one district pressure regulating station must be equipped with a telemetering record pressure gauges to indicate the gas pressure in the district line. 5942, on distribution system supplied. A single district pressure regulating system designed to determine the necessity of installing telemetering recording gauge and supply line, taking consideration number of the building, supplying operating pressure capacity, and installation and other operating conditions. Alright, 6. Materials and equipment. General requirements. Materials and equipment that will become the permanent components of the gas distribution system, suitable and safe for the conditions of the locality in which they are installed. The minimum components will meet with the requirement of the Title 49 Code Regulations 192. Extent practical, all materials meet the requirements of ANSI B31-8 and the approval of the gas supplier. Plastic or steel pipe preferred with the distribution system. Cathodic protection is mandatory. Underground ferrous gas distribution line stations will provide the testing with the cathodic protection system. 6.2. Equipment specifications. The designer must specify equipment compatible with the specific system materials operating requirements in every case. Safety requirements for the equipment of the gas piping system will be comparable with those of the piping components. 6.3. Plastic pipe. In the view of the rapid progress of the technology of field of the plastic pipe materials, engineers should consult with the latest issue of the AGA Plastic Pipe Manual for Gas Server, the Title 49 Code Regulations, Part 192, and ASTM Standards on Plastics. In addition, the latest information issued manufactured plastic pipe. Piping components will presently detail specific properties of the recommendation related with the products. 632. Plastic piping materials significantly more resistant to the corrosion. Metallic piping materials being used in distribution of natural and other fuel gases. Galvanic corrosion plastic does not occur since all plastics are non-conductors and are not subject to electrochemical reactions as are metal. 633. All plastic pipes are significantly lighter than the same size metal pipe. Compared with a steel pipe, weight advantage varies approximately 8 to 1 for a polyethanol pipe, about 4.5 to 1 fiberglass pipe, and thus easier for the construction crews to handle the plastic pipe. Alright, 7. Miscellaneous. 7.1. Odorization. Suitable malodorous agent is injected into any gas which does not pose a natural distinctive odor for the purpose of detecting leaks. Unless the gas supply line has been already odorized with the gas supplier, will be necessary to provide facility with injecting malodorant. Storage tank of the control of the device injecting odorization agent at a rate proportional rate of the gas flow to determine the pressure drop across an orifice will be required. The point of injection will be downstream side of the central regulating metering station. Recommendations can usually be obtained with the gas supplier type of the quantity with the malodorant for the use of the suitable injection system. 1.2. Liquefied petroleum gas or LPG systems. Liquefied petroleum gas usually include butane, propane, or a mixture of them, which can be stored as a liquid under moderate pressures of 80 to 250 psi gallons at ambient temperature. Liquid liquid petroleum gas distribution system designed to comply with the requirement of the National Fire Protection Association 58 instead of the ANSI B31-8. Polyethanol fiberglass will be not used in the liquid petroleum gas systems. 8. Your plans and engineering data. Plans. The plans will include layout drawings showing the entire distribution system, detailed drawings clearly showing pipe size, locating gas mains, surface conditions, details, abandoning pipes, valves, regulators. ANSI B31-8 requires abandoned gas lines to be physically disconnected from the gas sources. Shut-off valves are not acceptable means of disconnect. 8.2. Engineering analysis. The engineering analysis will be a diagram form showing all connection load, flow, quantities, pressure, location regulators. Please says supporting calculations will be prepared. Note will be included on or will accompany the diagram indicating specific gravity of the gas, heating value of the gas, BTUs per cubic foot, base pressure, base temperature at which the cubic foot of gas is defined as the flowing of the temperature of the normal atmospheric pressure, such as information as may be pertinent. Alright, 8.3, Plastic Pipe Engineering Consideration. The American Society of Tested Materials D225-13 presents engineering data, thermoplastic piping, tubing, fittings intended for fuel gas service. The the American Society of Testing Materials D25-17 presents engineering data for fiberglass pipe and fittings, including adhesive into the fuel gas service. The ASTM D3350 covers the identification of polyethanol, plastic, and fittings material using self-classification systems. Specific plastic material should be thoroughly investigated for the gas for the operating conditions anticipated should be adequately resistant to liquid and chemical atmospheres which could be encountered with the gas distribution system, tougher than enough to withstand stresses which may be imposed with the external as well as the internal force acting on complex piping system configurations. Alright, 8.3.1, Engineering Design Concept. The plastic include plastic pipes are different from the yield of the design with metals for metals in the air ambient temperature. Some considerable fraction of the yielded strength is widely used for design purposes. And ambient temperature plastics, unlike structural materials, are in floor. Unlike structural metals, are influenced by duration of stress with a relatively small change within temperature. Therefore, design stress level of the plastics are based on long-term strength and measured by plotting stress failure, function time, constant temperature. On short-term strength basis, design stress level for the plastics would be relatively low. Also, plastics therefore appreciable increased strength temperature reduced below the design temperature. Applicable to describe the appreciability decrease in strength of temperatures are raised above the design temperature. In fact, temperatures of 38 degrees or 100 degrees Fahrenheit, there could be significant differences among polyethanols on the same type of the grade. Plastic pipe users should obtain specific stress temperature data for the material being considered. 8.3.2. In addition to long-term strength, there are other properties which must be considered when selecting material for fuel gas distribution. The properties include corrosion, chemical resistance, aging resistance, weatherability, storm strength, temperature relationship, toughness, permeability, flexibility, susceptibility to rodent damage. With all these properties important must be considered that only long-term strength of the defined is enough to present time to be used as the primary basis for the design. However, the consideration effective of the other properties must be given the proper attention determining suitability for the intended application overall factor of safety. Alright, 8.3.3. When selecting a plastic piping system, the design engineer should relate with the insulation surface requirement of the characteristics of the several plastic systems available. Some of the factors are considered are design pressure level, the function required wall thickness, chemicals which naturally unavailably present are added into the gas system, affects maximum minimum ambient temperature, insulation practice, particularly with the tie-in points, insulation requirements, flexible type, semi-rigid type material, the suitable material for making plastic to metal connections, special design insulation requirements available, the necessary fittings and tools, fabricating piping system in the field, capability, compatibility of the material developed, and satisfactory operation maintenance procedures. Alright, 9. Your gas distribution system design. Introduction. The design of gas distribution system will be based on the demand maximum probable equivalent not less than 80% of the full maximum possibility connected to the appliance load. Actual consumption will never be equal to the maximum probable. but such diversity factor may exist when would serve as a margin of safety to not include the design of the site of the section. Distribution system serves no more than 15 buildings in an isolated area. In-service line with individual buildings will be based on full connected appliance load and various gas flow. Alright, your formula demand usually expressed in cubic feet per hour. Because of the variability of the volume of the gas, change of the pressure of the temperature, rough and the finite basis of the pressure, temperature of the necessary expressed in quantities volumetrically, is essentially the state of the characteristic of the gas for the computations, connection for the appliance load with the flow of the formulas, U for the design piping system, and all be on the same basis because base conditions 6 degrees Fahrenheit, 14.7 the PSI scaled according with the AGA or familiar with the natural gas report number 3. Flow conditions. There is a pressure loss in the pipes through roughly proportional to the square of the velocity. Therefore, there are two distinct flow regimes in pipe: laminar pipes and pipes, laminar and turbulent. There's a distinctive discontinuity with the behavior of the fluid with the laminar flow rates are exceeded with a large region with a mixed flow behavior. Partially turbulent flow exists between the upper limit of the laminar flow and the behavior of the pipe's fully developed turbulent flow. The exact transit regions between the various flow regimes are not yet accurately predictable of various flow gas piping situations. Of practical importance, gas engineering practice has developed practical approximations of working around the inadequate defined area. It's only a very unusual situation to lack exactness of any of the practical economical importance. RC, distribution system design criteria. The distribution science design are rarely designed with a total new system. The design will generally consist of the chain with the existing system, every knee with the system, and left with a complete with a clamp. Basis for the other military facility with unpredictable loads. For the most compelling with the problem with the distribution system designer is infrequency of the system operation operation at or near design capacity. Are your flow of natural gas in pipelines. Plastic pipes are very smooth, slippery surfaces with a friction resistant with considerable less than that of the steel pipe. Therefore, they often are assumed that the plastic pipe has infinite more flow capacity than a steel pipe. The assumption would be corrected under the fully turbulent flow conditions, such as encountered water with the investigation flow with the natural gas distribution indicates for the design flow usually fall within the range of the only partial turbulent flow. See table 1 for the indication of the typical flow rates for the gas distribution. In this range of smoothness of the pipe equations apply with the time of both the plastic and steel. Therefore, the pipe will the roughness for the not significant factor flow formula is found to be satisfactory for the sizing of the steel pipe and the natural gas surface recommended with the sizing of the plastic pipe as well. Sterilization must have, however, be given with a difference of inside diameter, large pipe size of the plastic pipe. Wall thickness are likely to be greater than those of the steel pipe. Distribution system flow equations: fully turbulent flow, rough pipe flow, flaw. The equation over a fully turbulent flow is also follows this equation: partially turbulent flow, small pipe flow, law. Any of the accepted gas flow equations used with steel pipes, such as the Mueller and Pohl and IGT distribution equation, could also be used with the calculation basic of plastic pipe flow capacity. These equations yield conservative values. The steel pipe will be conservative for plastic. Your IGT distribution equation is thought to be the representative of both steel and plastic for most distribution design situations as follows. And then it shows Q is equal to 0.6643 T, and it's kind of bad, like definition of terms. The terms used in the following equation: D is inside the pipe diameter, G is your specific gravity, and L is the length of the pipe at the section. B base pressure at 14.73 psi. P1 upstream pressure psi, downstream pressure at psi. P2. Q is gas flow rate, the MSCFH, thousands of the standard cubic feet per hour. TB temperature, base temperature 52 Rankine. T average temperature of flowing fluid Z is the average compressible factor. This little mark is the velocity of pound foot per square. Okay, effective roughness of the pipe surface inches, and then that equals at 0.0006 for plastic, 0.0007 for steel, and 0.001 for cast iron. Alright, using flow formulas, figure may be to determine whether the rough pipe or the smooth pipe of the flow law shall be used. The flow rate expected is above the curve. Then the rough pipe should be used if the flow rate falls below the curve. Smooth pipe flow law is applicable to the smooth case if the flow is rather high in comparison to the pressure drop between the plastic pipe and the steel of the core cast iron is desired. The following is suggested. Determine whether the partially or fully turbulent flow formulas are applicable to Figure 1 using given flow and pipe size. Alright, Figure 1 shows the flow of the range of the smooth pipe of the law equation linear flow equation partially turbulent flow with apply with a steel cast iron turb pipe. At the consideration there is no advantage of the plastic because of the reduced pipe surface friction. In Figure 1 show the rough pipe flow to fully turbulent flow applies then there. 3. Then there. You have your nominal pipe diameter in inches. You have 2, 3, 4, 6, and 10. And your flow rate in 1,000 cubic feet per hour. Typically, the maximum flow rates experienced are in 60 psi natural gas distribution systems. This shows your flow rate, your fully turbulent flow conditions plastic, and then fully turbulent flow conditions steel, and fully turbulent conditions flowing cast iron. And that's based upon the IGD distribution system. Fully turbulent equation K 0.01 for cast iron, and 0.0007 for steel, and 0.00006 for plastic. Gravity at 0.60, and your sun and pros at 0.105. Applicability of partial fully turbulent flow formulas. Maybe some advantage of plastic pipe depending on the relative wall thickness. Our verification system, dress your problem, the same project for the domestic gas suppliers, verify supply system pressure drop with the designer. Upon submittal of the plan of the distribution system, gas suppliers can be very quickly verify the supply system pressure drop in commercial available to slide rule type engineering calculators or prepared computer programs. This service is usually provided at no cost to the designer. Alright, your quiz. And then we'll cut the tape there because I'm going to take the quiz. And this was a reading from an introduction to gas distribution.